Hi everyone, I guess you can consider this a part 2 to my prior video. I didn't think I was going to be making a second video about physics, but I think there was an improvement and I made some new conclusions. I'm not sure if you want to call them discoveries, but anyway, here we go. This time I have a script, so it shouldn't be as rambly. Imagine a view of Earth from space, as someone standing on the moon might see. There is Earth, and maybe the sun far away in the background. From there, imagine the view transforming into Einstein's view using curved spacetime. Imagine the Earth as a marble sitting on the fabric of a bedsheet. In Einstein's view, the speed at which time passes, from the observer's perspective, is represented by the height of the sheet across space. In some places, the sheet is higher, and therefore time passes faster, while in other places, like near the marble, the sheet is lower and time passes slower. In Einstein's view, the passage of time varies with the amount of gravity experienced from mass. To expand on Einstein's model, I would like to consider the degrees of freedom of both time and mass. If time is the height of the sheet, it can move up and down, so time is represented by one dimension, while the mass can move left, right, forward, and backward. It is two-dimensional, even though the picture is three-dimensional. That one's kind of interesting. Let's do a few things to change our perspective. Let's reduce the space to one dimension, a single point, and then redefine the timeline not as a rate of time passage, but as a measurement of time passage. And then 3, fix the point in space, so now the timeline is moving upon itself through the point. It would look something like that. And what's happening is I'm saying instead of the time being a rate if it's high or low, it physically is moving down through this point. That is what time passing is. Now let's reconsider our representation and what effects it can cause. A point is a spatial dimension, therefore it has space, just no volume. There are a few things that could exist here. That would be the force of gravity, the force of an electric field, and the force of a magnetic field. Gravity is the only force we are qualified to talk about at the moment. It is the only static force field that we understand enough at this point. You might think gravity requires mass, and therefore it requires volume. I'm implying the existence of gravity without mass, a gravitational energy. We know a few things about gravity. It travels at the speed of light. It is denoted with a giant G, the big G. It applies an inward force. I propose it is the force, or part of the force, that creates space and potentially time. I propose it is part of what we call energy density, and I propose that this energy density must be in the form of a wave, albeit a wave from another perspective. Consider a wave propagating through space. However, the distance between space has a wave-like variance. I'm saying that gravity is the longitudinal wave component of electromagnetism. What I'm saying is this part is the longitudinal wave, the frequency. Imagine a bug crawling on the floor. Oh, a flashbang warning. The next one I'm going to show is all white. This is what I'm trying to say. We have the electromagnetic wave, and the gravitational wave is the longitudinal wave component. Here, in this example, the gravitational density is changing. Now, let's think for a moment. How can a wave propagate on the T1 plane, which in this picture is the red plane that we perceive with the crosshatch pattern, if there is no space? So this is before that second point exists. There would be no other space to propagate into. That is why I said gravity is the force, or part of the force, that creates space. An energy density oscillation is what initially created the second space and formed a one-dimensional line. Interestingly, there are 2 expansive forces, electromagnetism, and 1 compressive force, gravity. To me, this hints at why expansion might be taking place and how one point became a line. In this slide, I'm trying to compare what I believe a singularity is to how a zero-dimensional space became a one-dimensional space. The energy density created a wave, and the longitudinal part of the wave is the gravitational part. But it can also carry energy density. And I believe that that is what created a second space. Now, gravity also has a second effect, and that is that it pulls things in. So it can carry energy, but it also pulls things in. I propose that time flows slower in the T2 direction due to gravity, because gravity also affects spatial density. If my idea that each space has its own time is correct, then gravity is not just spatial density, but also temporal density and a longitudinal force. All three share the name gravity currently. So now we can re-examine this picture with some more context. A fluctuation in energy density deflects T2 into another spatial dimension. So the energy is used to create space, and that space has time. Then that space allows for energy to further propagate or be converted back into time flow in the T2 direction. So when the time flows at a space, energy is being converted back into time. As I mentioned before, the maximum speed of this propagation is c along our viewing plane, which is the T1 plane, the red crosshatch plane in this example. Notably, magnetism and gravity are coplanar with our perception. This means temporal effects from the T2 axis on the T1 plane are unmeasurable from our perspective. Imagine trying to measure magnetism. Even static magnetic fields are coplanar to our view of time every time we measure them. The same is true for gravity, except it's longitudinally propagated. I believe this means that gravity is continuous, whereas magnetism is discontinuous. So from there, I decided to create this diagram to help me understand different temporal perspectives. The top row is all self-explanatory, and then the photon is instantaneous energy that is measured as a solid, right? It has momentum even though it has no mass. And then mass, that one measured, I would assume produces gravity, but it only exists when it's measured. From there, I was able to fill in the rest of the graph. Since I have mass here, mass up here, this one would be mass. And then I have electricity. So this one would have to be electricity. And then I have electricity, mass. This one would have to be magnetism. You can just fill in the rest from there. Just to help me understand what different temporal perspectives might entail. So the premise for my thoughts was that mass and gravity are continuous over time, and that it is restricted to a light cone field. If we say that mass was created, then the shape of the cone on the top left is a logical representation of how that continuous force field and mass persist. The cone is based on the speed of propagation, c, which means that the longitudinal waves affect the cone's angle, not the continuity of the cone. This is perfectly captured by my picture from the prior video about how gravitational effects propagate. And here's one of my favorite slides that has this view. It's like a 3/4 view and then a top-down view of what might be occurring. And then this one is from the previous video. So I thought I should consider, why does a photon change its path? In this example, we have, I'm trying to deduce if it's related to gravity. So we have an electromagnetic mass, which is a moving electron. It has gravity because it's mass, and because it's a moving electron, it also has electromagnetism. And then here is a photon. It has no mass. However, I believe it probably has a gravity component in its field. However, since it has no mass, and this one has mass, gravity cannot pull it in because it has no mass. So what is causing it to change angles? I believe that this has to be temporal friction, if you will, that I discussed in my last video, and you can also see it on this slide. The key is to view gravity as spatial density and therefore a temporal density, not as a force. When viewed as a force, gravity would be required to act on a photon which has no mass. it would also require the measurement of a photon, meaning that all space with gravity would collapse waves due to measurement. Photons would have to travel as particles because they've been collapsed or measured. Mass would be pulling at photons when they pass by. All of those things don't happen, which is why the perspective's incorrect. Gravity must be thought of as a spatial density, which is a temporal density. This perspective can allow each space's energy density to interact through a common medium. Gravity is a static force from mass that requires T2 time to flow. So how could mass or gravity exist at a singularity if T2 time is not present at that point? And this takes us back to the prior picture. And now I'm talking about the right side. I propose that singularities must lack mass, since mass requires a non-zero amount of space. I also propose that singularities lack gravity within, since they have no spatial density. My explanation is that a singularity acts like a static electric field, where gravity can only exist outside the temporal radius. The new space is very slowly created at the edge, using this energy. Hawking radiation is the effect of time passing at the radius. One component is allowed to pass through time, the T2 axis, or field, most likely creating space, while the other passes through T2 at another location, causing an effect. They're entangled, which is also what I mentioned in my previous video. At the edge of a black hole, there's entanglement. In the left picture, I believe gravitational wave energy is converted into space. This is most likely why space, as we perceive it, reduces all three forces. Electric, gravity, and magnetic forces all are reduced over space, right? So why does the inverse square law exist at all? Well, it's because the energy is being consumed as it travels. I think this might be why. Now, you might have noticed that I was switching between 0 and 3 spatial dimensions at will, even though these are different perspectives. Well, temporal energy and spatial energy are interchangeable at a rate of 1-to-1 as far as I can tell. And here's my diagram kind of hinting at that. I realized while creating this theory that the interchangeability of spatial and temporal dimensions is the key to changing perspective, and possibly the expansion factor itself. That's like the Hubble constant, which I don't know, I just intuitively believe it to be e squared times 10. Now, if you look at the three main viewpoints, there are different amounts of temporal and spatial dimensions, and interestingly, the bottom two have the same amount of temporal and spatial dimensions, but in a different configuration. And I'm saying we're able to convert between them because I think it is recursive or periodic. Take, for example, the top row, what I call the quantum scale perspective. We have explored the 0 and 1 spatial dimensional views earlier, but what if I said that the space was actually 3 dimensions at that point? Well, the T2 line would be dictated by an extra dimensional mass, so it would actually go up to 4 dimensions. And I say this because mass radiates gravity, which the gradient of is parallel to the flow of time due to temporal density. This is also Einstein's viewpoint. So now we have the 4 spatial dimensions. However, doing some logic upon the necessary temporal dimensions results in the conclusion that they can be reduced, with no change in the underlying logic of the system. Basically, the quantum perspective can be shifted to the universal scale perspective by trading spatial and temporal dimensions. So I'll just quickly explain some of these. We have the 9 temporal, 0 spatial, and I'm calling it 1 energy dimension because massless energy enters somehow. I would like to say it's through the T2 axis, or a 4th spatially oriented dimension of time, which I can't even really comprehend, but there'd be some way that energy can flow in. And then the second one is the 9 temporal, 1 spatial, so that's to the right, the top middle, and it's the linearization of space creation. So that would be the effects that allow photons to travel, or that created the second space if we did start from like a singularity type origin story. And then there's the 8 temporal, 2 spatial, so that would be the bottom left. And I believe this is related to magnetism. The T2 field would apply to the whole plane. However, there's an extra half a temporal dimension, and maybe that's why magnetism has weird effects. Like maybe there's two sides to this plane, is what it's trying to say. Probably needs a little bit more exploration by somebody a little bit more intuitive with the math. And then there's the 7 temporal, 3 spatial, which is the bottom middle. So it's a 3D space with no orientation timeline. So what I mean by no orientation, well, I mean this whole thing is rotatable in in every sense. Like the time 2 field is just flowing down as compared to the space. It is not flowing towards a point. Whereas the top right, which is a 6 temporal, 4 spatial, it's like the 4-dimensional relativity viewpoint. Time flows on the T2 axis in a stable direction within 3D space. So we're always flowing towards the future. And maybe the mass is outside of our 3-dimensional spatial understanding. And that's why time is always flowing in, like, you could call it like an esoteric direction or something. And you can see how there's the initial line of time, T2, there's one of them. And then there would have to be a plane to apply to that. So there would be a 2-dimensional right there. And then a field to apply to that plane. So 3 more dimensions. That'd be 6. However, I believe there's also a second version of that. I call it the 222. And it's 222 time and 4 space. Discrete spin states align results perpendicular to time planes, or maybe even coplanar to them. I believe this is represented through electromagnetism, mainly like spin states and stuff. And then I did create a 5-dimension one with a hypercube and a T3 field going through it, as well as a 2T plane intersecting it from the 4th dimensional axis. It creates a line, as far as I can tell. Although this one is more of just a thought exercise. I don't even know what it would apply to. Maybe it just ends at 10. Maybe it's not recursive. It brings up some interesting questions, like does each point in space contain an infinite number of dimensions? Or is the amount of energy needed to create / sustain them like encoded in the space itself? I'm inclined to say there's like at least 10 dimensional perspectives. That's just because they can trade off 1-to-1, right? And I think it's really interesting, as I spoke of earlier, with E squared times 10 being very similar to the Hubble constant. But besides the more theoretical stuff, what does my framework actually do? Well, it allows for us to say why photons are detected as solid energy, why photons travel as waves and are measured with momentum, how force waves entangle, why photons are affected by gravity without the use of Einstein's spacetime model, why entangled photons travel instantly, why black holes emit Hawking radiation, and why quantum probabilities are waves of EM radiation. I think there's probably some more information you could get about gravitons. However, I don't think I understand what the theory is on those quite enough. And I also left this picture out. I couldn't find a good spot to throw it in there, but it is a photon traveling. Unfortunately, I used yellow and orange, but there's a mass here and a mass here. And I indicated this as a mass, but it's also the initial point where the photon originated from. So the wave travels out, and as I showed earlier, it is influenced by these T2 dense regions, and the temporal friction is what's causing it to bend, whereas the gravitational force is applying longitudinally to influence the wavelength itself. And I think one great question is whether or not photons are teleporting or traveling instantaneously. I feel like I can think of a few arguments for both, but I can also think of a test that might be able to detect it, and that would be using a laser pointed at something like the sun, which is 8 light minutes away. And then in the time that the waves are traveling, from the initial point of the laser, I would assume photons are still at that spot in space. When the wave is traveling there, you install an apparatus to measure a potential one-dimensional photon travel as the wave collapses 8 light minutes away. I'm not sure how hard it would be to detect a one-dimensional photon particle as it's traveling at an instantaneous speed, or potentially just teleporting there. That's one avenue that maybe something can be actually measured to find if this is true or not. And then I just want to clarify my one of the most important things is that there's a difference between gravity and spatial density, even though they're both at least proportional to g. I don't think they are exactly the same. So I think that's where I'm going to leave it. That's good enough for getting some people started on this new idea. Maybe we can come up with some actual ways to test and measure this. It seems pretty difficult because we're dealing with the time scale of time itself, or measurement itself. However, this framework does at least allow for logical and reasonable sense applied to quantum effects. Thanks for watching. Please consider subscribing or donating to Patreon. I am a poor college student after all.